All right, folks, it's Back in Action here. In this video, we are going to introduce the definition of a sequence, and then we're also going to look at two different types of sequences and how to write the rules for those, working with just our basic formulas. So let's just jump in here at the top and let's look at our definition of a sequence. A sequence is just a function whose domain is the set of positive integers. Now, that's a pretty important detail here, that the domain is only the set of positive integers when it comes to a sequence. So, for example, if I told you that this is a sequence, notice that we're using a different notation. Instead of y, okay, so instead of using a y here, we're going to use an a sub n, and instead of an x, we're going to use our n's. So we are replacing x and y with a sub n and n. Now, since we are saying that this is a sequence, the domain of this, we can write this in our set notation, n instead of x, such that n is greater than 0. So our domain is always going to be something positive, and then we also want to indicate that n is an integer. Meaning we can't have any decimals here. So our n values, what would normally be our x's, are not going to be integers at all. Now, when we look at this notation, a sub n, we're really thinking y, okay? And then our n's are our x's. That means that a sub 1 is what we would call the first term, okay? So that would be called the first term in the sequence. So a sub n simply means we're going to substitute that 1 where n is in for 1. So 1 minus 1 over 1 plus 1. That's, of course, going to give us 0 over 2, which is just going to be 0. A sub 5, then, is going to be the fifth term. So a sub 5, again, we're just going to substitute in. Of course, you could do this mentally. 5 minus 1 over 5 plus 1 is going to give us, oops, meant to say a 4 there. I got ahead of myself in my writing. So this is going to be a 4 over a 6. Now I could reduce that, but I'm not going to reduce that right now. You'll see in a second. Over here, we're going to write these first 5 terms of the sequence. That means we're going to find when n is 1, 2, 3, 4, and 5. Now we actually already found 2 of those, and our first term is 0, and our fifth term is 4/6. Again, I'll reduce that in a second. So now let's go ahead and start substituting in. If I substitute in 2 here, I'm going to have my 2 minus 1. I'm going to do this a little more mentally this time. So my 2 minus 1 is going to give me 1. My 2 plus 1 is 3. I keep going. 3 minus 1. Again, we're just substituting into this little formula here. 3 minus 1 is going to give me 2. 3 plus 1 is going to give me 4. I'll reduce that in a second. And then let's go on to 4. 4 minus 1 is 3, and 4 plus 1 is 5. So here's what I want you to notice. I'm going to go ahead and put a nice box around these 5 terms, and then we're going to add a little bit to it. First, I want you to notice, let's ignore the 0 for a second. I want you to look at the numerator here is going 1, 2, 3, 4, and our denominator is 3, 4, 5, 6. That should make sense because the numerator and the denominator of this sequence are both linear functions. So that pattern makes sense. Of course, if we extended this down, 1 minus, and then subtract 1 here gets us to 0, and this was our 2 that we had. Now, certainly we can reduce these values and make these a 1/2 and make this a 2/3, which you would want to do. But at least until we reduce it, it's nice to see those particular patterns happening there. Now, we're going to take this idea and we're going to drill it down into 2 specific types of sequences called an arithmetic sequence, looks like arithmetic, and a geometric sequence. And we're going to look at some rules. Now, I don't want you to get too worked up about trying to get these particular formulas memorized, because we're going to extend this one as we move into chapter 3, and this one is actually one that you've already seen. So if we have an arithmetic sequence, in particular, an arithmetic sequence is a sequence where the difference between each term remains the same. In other words, the rate of change is constant, and we have already discussed this year, this is a linear function. So an arithmetic sequence is another name for a linear function that just has a very specific domain. Now, this general rule, this is another way of writing basically the equation for a linear function. And I'm going to rearrange this. Remember, a sub n is the sequence notation for y, and n is our replacement for x. I am going to go ahead and distribute this d here, and we're going to write this as a sub n plus dn minus d. And dn is like our old mx. So I'm going to put that first, and I'm going to write dn. And then I'm going to group these two together, and this is going to become plus, and I'm going to put a parenthesis to make it a little clearer, a sub n minus d, and this is our old b value that we would have had in our y equals mx plus b. So this formula is just the equation for a line, and we cannot emphasize that idea enough. So let's take a look. I'm going to come down here, and I'm actually going to work down. I'm going to work all the way down this side here to do all of our arithmetic rules simultaneously. So the first thing we would want to do on this one, where it says determine the type of sequence and write the general rule for the nth term. The general rule for the nth term is this idea, and we'll of course see it with the other form as well. So if we look at this, what we would notice is we would say, hey, I can see that this is going up by 5 and up by 5 and up by 5. And if I see that, what I'm thinking from earlier in the year is that the rate of change is constant. We would previously said that that was linear, and now we're going to say that this is arithmetic. So this is one of those places where, yes, it's linear, but if it's asking for the type of sequence, we would say arithmetic. We don't call it linear, we call it an arithmetic sequence. Now, if we want to write that rule, we need to use the sequence notation. So we're going to say a sub n, not y. And then we're going to recognize that this 5 is our slope, but we're now going to call that d. It's our difference. So this is going to become d. I didn't mean to write d, I meant to write the 5 there. We're going to write 5n. And now we need to find that old b value from up here, and that's going to be our first term. We can see this here is -7 minus our difference of 5, and that's going to give us -12. You can hear my cats going. Okay, so this is our sequence. Notice it's just the equation of a line there. Now, we can extend this a little bit more, and we can look at, well, what happens if instead of giving you the sequence, I give you a term and I give you this d as difference. What I want you to recognize here is that because this is a d, it automatically means that this is arithmetic, which means linear. Okay, that's what we're thinking in our head. Don't get too wrapped up in that idea of the word arithmetic. It's just swapping it out for this new idea. We can also take this sequence or this term here and write it as an ordered pair. We know that the 57 was like the x value, and the -337 is like the y, but we're going to rename this. We're going to remember that this is now an n, and this is a sub n instead of y. Now, if we wanted to write the equation, and then of course our d was like our slope, we can still go back to our good old point slope form. So instead of having to worry about this formula up here, we can use our point slope form from our just algebra days instead. So instead of saying y minus y, we're going to say a sub n minus that -337 or plus 337. And then I'm going to take my difference, that was my good old slope, -7. And now I'm going to say n instead of x minus 57. And if I just rearrange this, I will get a sub n negative 7n plus, and I've already done this math for us here, we'll get 399, subtract my 337, and our rule is a sub n negative 7n minus 62. So notice that we didn't really do anything different here, even though it looks more complicated. We just wrote the equation of a line, and all we did was swap y for a sub n, and instead of x, we put n. Okay, now let's look at our other type of rule. Our other type of rule is a geometric sequence, and we're going to do a lot more with these in our next chapter. So a geometric sequence specifically says the ratio, that's an important word, the ratio of each term to its previous term. That order is important. The ratio of each term to its previous term remains the same. That means that this is going to be exponential. Now, when we look at its general rule, a couple things that I want you to notice about this. We have our first term. So our value in the front is always going to be our first term. The r, okay, is going to be our rate. But in terms of an exponential in the past, you would have called this your base. So again, we're just giving some new names to things you've already done. The other interesting thing about the way they write this formula is that the exponent is not n, it is n minus 1. So just give yourself a little reminder here that note that this is not just an n. It's not just raised to the power of x or n in this case, it's specifically n minus 1, and we do want to follow that pattern. So similar to what we did over here on the arithmetic side, the first thing what we want to do is we want to look at how would we recognize a geometric sequence. Well, the first thing that you would do is you'd notice that, hey, I'm not adding the same amount every time, so you automatically know that it's not arithmetic. So then the next thing that we would check is we would check for that ratio. Now, the order of the division matters. So I have to do 6 over 2. I cannot do 2 over 6. It has to be the term over its previous term. So I'm going to have 6 over 2. I'm going to have 18 over 6. I'm going to have 54 over 18, 162 over 54. And if you type all of those in your calculator, you're going to see that you get 3 all the way across, and we're going to call that R. So this rule is actually really, really easy to write as long as you can find that ratio, because we already have the first term, we have our ratio, and you really just need to follow the order. So a sub n is going to be my 2. Remember, the first term has to go in front. Then we're going to have our ratio, and we're going to use an n minus 1. Students will often ask on this, hey, Ms. Bass, can I write this as an exponent of n? And the answer is yes, you could write that as an exponent of n and still get effectively the same formula. But if we are following the rules of a geometric sequence, we need to follow that particular formula. So it does need, for a sequence process, to have the n minus 1. The next thing that we're going to do is we're going to look at a little more random case here. So similar in idea, we're going to have, we already know the ratio. So that's convenient because they said it's a ratio, the R. We know it's geometric, which means it's exponential. That's how you know which formula you need to use, just based on this given information. Then we're going to take this one term they gave us, and we're going to write that as a nice ordered pair. So 6 negative 1,536. It doesn't hurt to remind yourself that this is n and this is a sub n. We'll use that in a bit. And now we can start substituting into our formula. So we're just following this formula from up here, but what we're going to have, sorry about that, but what we're going to end up having is we're going to have a missing variable. So we're going to have to do a little solving before we can finish our formula. You will want a calculator handy. So negative 1,536, that was a sub n. we do not know the first term. We do know that the ratio is -4. And the numerator here would be an n minus 1, but our n is 6. So we can say 6 minus 1. So let's clean this up. -1,536. This is a sub n. I have -4. This is to the 5th power. I can clean this up. This is going to become -1,024. I would not expect you to do that in your head. So a sub n is -1,536 over -1,024. If you type that in your calculator, you will get that a sub n is 1.5. So now our rule is a sub n. You always have to have that. Our first term, our ratio, and it has to be n minus 1. Okay, so that is all of the basics of the formulas. In the next video, we're going to go into one more advanced example of finding a rule, and then we're going to look at what are called series and sums.